Good afternoon, Benji. How are you?
Hey Jeff, yeah, I'm
Can you
good.
hear me
Hey
clearly?
Michael.
Apologies.
Yes,
I've been having
perfect.
headphone struggles.
No, it's perfectly fine.
All right, cool.
Hey everyone, hi Jeff.
What's going on?
All good.
Nice.
Okay, let's wait 10 more people joining.
Have y'all met Shane yet?
No.
All right.
No.
Well, that's Shane.
Hey, Michael. Yeah, we met in Seattle.
Oh yes. I remember. Sorry.
No, you're good. Yeah, I'm sure a lot of people coming out.
Hey. And joining us new from the Apollo side is Simon as well.
Hi Chris.
Hello.
I think we are still missing Kanne, so let's give it 2 or 3 more minutes. Yeah, he's coming. I just pinged him.
So many months since the pandemic, and I still haven't figured. Headphones do not do what I want them to do. You might need a second pandemic for this to work.
I'm just glad no one is showing up as a Vision Pro persona yet.
Not yet. Give it a few
Nope.
years.
We had
Or
Apple
weeks.
developer. We had Apple, one of Apple's people reach out to our iOS team to talk about like adding Vision Pro as like a compiler target or something, supporting that. And our lead maintainer replied back saying like, "Oh, we're going to need some hardware samples in order to ensure compatibility."
Sure.
They didn't find that funny for some reason, but I thought it was great.
Yeah. Unfortunately, in the back end, we never can say that.
What you need some hardware samples. Do you want some Azures for home?
We have 12 people on the list and 12 people on the call. That said, I see Yakov on the list and he's not on the call. So some of you I don't think are in the agenda yet. If you can send a pull request, that would be appreciated.
Hey, Benji, it's probably me. I'll probably add up. Yeah, right now.
Perfect.
And I'll need to do that as well. Hey everyone, my name is Sandeep. I'm Praveen's co-worker. Hey, Benji.
Right, I'll give it another few seconds in case Yakov is joining us. And then we'll kick off. In fact, we'll kick off now. Hey everyone, welcome to the Composite Schemas Working Group. By being here, we have all agreed to the specification membership agreement, the participation guidelines, the contribution guide, and the code of conduct. Links to all of these are in the agenda if you need a refresher. We'll start by introducing the attendees, introducing ourselves. We'll do that in the order that we are in the agenda. So that will start with me. Hello, everyone. I'm Benji.
I think I'm next. Hey, everyone. I'm John.
Yakov's not here, so hey, I'm Shane from Apollo.
I'm Jeff from Apollo.
Martin, also from Apollo.
Hi, Samuel from the guild.
I think we missed
Pascal?
Simon.
Yeah, Simon is missing, right?
Sorry, I'm Simon, also from Apollo.
Hi, I'm Pascal. I'm from Chili Cream.
Hey, Raphael from Shale Cream.
And Michael from Chili Cream.
You're muted.
But
Thank you. Hi, my name is Christian, here as an individual.
Hey, this is Praveen from Hasura.
Hi everyone, I'm Sandeep from Azure as well.
awesome.
Okay, thank you very much. I think that's everyone. Thank you for being here. Who would like to volunteer to take notes today? I'm certainly happy to help out on that front, so I will do so, but it would be great to have someone else covering, especially when I am talking. As I
Can you
can't-
post the can you post the link so in the chat so everybody
It is
can
linked in the
chime in?
agenda, but yes, I will do that also.
Myself and Jeff could help cover with notes here. Oh,
Fantastic. The link is now in the chat. Fantastic. So on to reviewing the agenda. We don't actually seem to have any real dedicated agenda topics today. So the first thing that we're going to do is try and catch up on what has happened during the secondary meetings. Michael, I might hand over to you to do that if that's okay.
Yes.
Perfect. And then after that, we will have a look, I guess, at the previous meetings' action items. And then on to general discourse. Is there anything that people want to particularly put on the agenda for today?
Okay, I'll take it over and then we can see where this leads. So the last couple of meetings, we basically organized ourselves. We have now a repository where we are working on. We marked this current spec proposal, or it's not even a proposal, it's a stage 0. So everything there is at the moment changing. We are basically just throwing pieces of text together and are going from the introduction, which has already a good state, further through the spec parts and forming out of that a common spec. So that is what we started. I can quickly show that. So we have a second repository, which is here the Composite Schema spec repository. And yeah, there we are tracking also the work with issues. Like Martin opened today a couple of them, like Benji and I had already a couple of them. So if you want to join, give feedback, that's the best thing to do is here with issues, because then we can also track the discussion and everybody can join instead of just having it in the meetings. We also, in the last couple of meetings, started a bit discussing terms. I mean here terms in sort of the spec language. When we go, for instance, to the overview, that is a bit outlining already the direction of the spec, like the important core design principles of the spec, but also lays out some language, like we talk about the composite schema at the moment. These are not, all the terms are not final and are up for discussion. We still have, like Martin also opened a discussion on that, and like we are walking through how we should name certain things. And we are doing that in regard also to the core spec. Like this is specification text. In the products, you don't necessarily have to take the same terms, but the spec has to have a consistent language as it is based on the GraphQL specification. So we are a bit, we're discussing their terms. As I said, like nothing is decided on until we all have agreed on terms here. So if you don't agree with any of the things that we have here, just open an issue and we discuss it. Like at the moment we are discussing the term source schema, for instance. That's something I think we came up with, but it's also the one that I'm not 100% happy with, but also haven't found a better thing than that at the moment. But like these discussions are actually happening here in the issues. Actually an issue that I opened at some point because like, for instance, Apollo would call that subgraphs. In Fusion, we call that downstream services. But when we talk about the GraphQL core specification, for instance, we're never talking about services. We're talking actually about schemas and executors. But there is also no term graph, for instance, in this. When we talk about what graph means, we are talking more about the schema. So we try to align that a bit more, that the spec language is consistent. But as I said, these terms are not final. So if you want to join in, you can join in this discussion. We have reopened that issue, so we can further discuss that. And then if we're happy with something, we can go through what we have in spec text and change that. So don't worry if you at the moment not yet agree with that. We also talked about a lot about the structure of composition. Composition is actually the thing that we mostly focus on at the moment. Like that's one thing. Let me go back before we go into that. Like in the overview, we also outlined the scope of the spec. That is something that we actually also initially discussed in when the TSC decided to take on this as a project. Was the scope, and that was a bit about like the first part is schema composition, and the second part is the execution. Martin has rightly said, like if we have a very strict spec that describes this execution in detail, then there is no you can implement a unique solution for your company. So we do it in the same vein like the GraphQL spec. Like the idea is to describe a fundamental execution, but like everybody can have a better execution algorithm for it. I think it's important to have a fundamental understanding of how the execution works. Like the GraphQL the GraphQL spec actually also outlines an execution algorithm, but most advanced GraphQL servers deviate from that. And Martin also suggested here actually a note that I'm actually quite happy with. What was it? This guy here, that we have something like this where we explicitly call out that everybody can deviate from that. So this gives everybody room to put all their own ideas into a product. Like for instance, Apollo Router will have their own way to execute things, and others will have other ideas on how to execute that. In general, also like we outlined a bit the spec, the directives. Like while the text is widely not finished, apart from overview, please read through that. And if you don't agree with that, open an issue on that, right? But we also have like agreed a bit on directives, roughly. But again, if your product that implements that has more directives, then this is totally fine. The spec is not, the idea behind the spec is not that we cover everything, but cover the core things so we can build tool that is interoperable. There's a question, Simon?
Yes. Does this mean that the execution algorithm is entirely outside of the normative specification? Or does it mean that implementation details can change, but as long as the observable behavior stays the same?
I think the latter. I think the important thing to call out here is that we don't want to specify, for instance, the exact format of a query plan, because that's something where different products will have different solutions, and it ties in with the specific like execution algorithms that are being used. So that at least in my mind is explicitly sort of outside the scope of the specification. But we do want to specify the observable behavior. I think that's the right level of abstraction. And that's in a sense is similar to what the GraphQL specification does, although it does describe things in a little more detail. But what's important there is also the observable behavior.
Sounds good.
Yeah, I mean, the observable behavior is sometimes the easiest specified with an algorithm. That's also what we observe there. It's just the most an effective way to define strict behavior, right?
Yeah, and the idea is if you have a better algorithm or you do it with query plans or whatever, that's totally fine. It's just so what I want to make sure is that open source developers that might not have the resources of other corporations can also easily get started with that. And that's actually what the GraphQL specification does very well, right? You can implement the algorithms and you get to an okay result. Maybe it's not the fastest, but you get a good GraphQL server out of it. Sounds good. Okay, what we also a bit like, and this is also like the details here. So don't get hung up off of that. We are discussing, for instance, names here, also could be parameters and whatever. But I think the set that we gathered as directives is quite good. I would say it's the best of what we gathered from Apollo, from Fusion. We mixed that together. And it's a quite good set of directives. What they are in detail, we will go through when we do the composition. Okay, so at the moment, that is like what I'm at the moment working on with Martin in the last couple of meetings where we discussed these. I think that's a bit the composition. So I moved actually a ton out of the composition at the moment. So we have, yeah, it's still a work in progress here, but we basically have 4 algorithms that we describe to make up the composition. And the first one is validate source schemas. Validate source schemas roughly is about validating the source schemas as if it is, for instance, a correct schema specification that we get in there. Other directives correct that are specified in such a source schema. Then we have merge source schemas.
One thing to call out here maybe is that it goes beyond the standard GraphQL validation,
yes,
because it also validates the semantics of these directives. So for instance, for a key directive, it would validate that the field argument is both syntactically and semantically valid as well.
Yes, but in isolation of the subgraph.
Exactly. Yeah.
It does basically like the standard checks. Okay, is the schema document correct? That is what also the GraphQL specification does. Basically, call out if there is a query syntax in there. But beyond that, it validates the GraphQL, the directives. Are the directives correctly specified, and also are they the applied directives correct? Yeah. And then we have here the merge.
Shane's got his hand up, I think.
Yeah, right.
Yeah, maybe this is a better question for outside, and because it might, I'm sure, bring up lots of discussion. But ignoring like the other directives you can add on, do we still think of a core principle that like a valid GraphQL schema that has nothing to do with composition or directives, any of these things, is still a valid composable schema, like kind of like the TypeScript model, right? Where a valid JavaScript file can be passed to the TypeScript compiler. Like you don't need to have any TypeScript annotations and it can still process it in some way. Maybe this, like I said, maybe this is something to bring out. If it has been discussed, maybe great. I'd love to like hear something, but if not, maybe I can start a discussion on that outside of this.
I think one related discussion that we've had is sort of implicitness and explicitness. Whether, for instance, we try to infer the meaning of root fields instead of relying on an annotation like entity resolver or finder. And it also ties in with the notion of like non-shareable by default. So there's definitely implications if you don't include any additional metadata in additional directives and try to merge a schema, depending on sort of the semantics we land on for composition, that might get you into trouble pretty quickly. So I would say in general, although we try to sort of limit what is needed from a, I keep calling them subgraphs for now. I think there's sort of a minimum of additional metadata that's required for most real world use cases.
I think that what we landed on was they should be valid GraphQL schemas, but we didn't require we only require additional metadata to behave well with other sub schemas or subgraphs.
And there's also like this was the discussion actually. Did we have it last time, Martin? We kind of maybe. Yeah, we discussed that it's in general we want explicitness, and if somebody it's a Apple listing, if you want to have a solution that tries to infer things, this could be done in a pre-processing. Like it could be that if we want to implement something like that, we could kind of have a composition tool that does some pre-processing and infers the directives, and then it ties into the standard algorithm again. Kind in that vein, this could run. And this would give, like, again, like we are specifying a core specification here, like how people implement extra things on top of that infer a whole lot of things up to the composition implementer. I think in that regard we landed.
Yeah, I think what we all agree on is that it's not going to be some special data annotation language like it's done with the Prisma in some ways. Maybe you have a custom DSL for federation. So all the existing tooling will work, IntelliSense, parsers, and stuff like this.
Jeff?
Yeah, so I heard the term core specification, and I remember one of the things we talked about last primary meeting was that kind of what are the bounds, I think, of a core specification? What do we share a common understanding of what constitutes a core specification, I guess? I know that we have a lot of detail already in the spec repository, which is great, and we are speaking very specifically about the details, which is wonderful. And I'm curious about what the bounds of that are. Like, does this group share a common understanding of what is in scope for, say, for the first draft proposal versus what is reserved for future proposals and such like that? Like, there's so many great ideas happening. I'm just curious as to how we're categorizing each one. So yeah, just more of a general kind of big picture question about where the assumptions we're operating under.
The general outline for what we cover with the core specification are basically the directives that we outlined. The shape and everything on that may change. But in general, the directives we cover is the thing that we want to allow for the subgraph. there are no things like authentication, authorization, policies, a lot of the things that Apollo, for instance, has already. That would be like Apollo's plus things that make no sense to dictate to everybody else, right? Apart from that, the main effort that we do for, I think, a while at least, is the composition. Describing the composition, how we get from a couple of subgraphs to an executable subgraph document. And the second half is really describing what the execution does in terms of in a more abstract way.
In terms of behavior.
Yeah.
Because the composition and the execution in some ways or forms also belong a bit together, because it depends on how you execute, you compose differently. So this is more or less the scope, I guess, right?
Yeah, and there's even a tighter connection between them in sort of the way we've been thinking about composition. Because one of the stages, like we only got to stage 2 of composition here, but after sort of merging subgraphs, and sort of validating the result of that resulting schema, we do sort of deep validation, something that at Apollo we've referred to as the fundamental property of federation. That might be a bit too grand to use here, but it's basically validating that every valid GraphQL query against the client schema can be executed in a distributed way against this particular set of subgraphs. And the way that's described in sort of a formal way also ties into execution. Basically, like validation at that stage tells you that there's at least one possible way of getting each field. And execution is about like generating an efficient way of getting those particular fields. But there is a close connection between them, and depending on sort of how we end up describing execution, like at what level of abstraction, there might be a common language there as well.
Yeah. So that what Martin just referred to as a satisfiability, I think we named it in validate satisfiability. It's basically making sure that the composition result, what comes out of the merge process, can be executed with all possible ways that you can get to certain fields. That's important because there are directives like provides that maybe annotate that if you come through this field and you're on this subgraph, then you can also get these information and things like that. Yeah. But that's the basic. So what we don't cover, and we might call that even further out, are things like, as I said, authentication, authorization, and all these enterprise features that each solution can put on the top.
Yeah, and also the kind of transformation directives that, for instance, Fusion, the Fusion spec specified, that would also be outside of the scope of the core specification here.
Exactly, that would be, again, go into some pre-processing that you could put before the actual algorithm, if you want to implement such a thing. Sounds good. Yeah, I think
I understand all that. Yeah, that makes sense to me. I think that the notion too of like how we express those core concepts too, and like naming decisions and things like that. I wonder what are the principles for resolving those, right? What is, for example, like the notion of what to call a certain directive, or like, we're referring to obviously some different implementation details there as like what are users using in production today? What are some ideas that we want to guide the community towards as time goes on? I think having a clear sense of what those trade-offs are, I think it's important too. Like the notion of whenever we're looking at naming, just minding what's compatible with things that are running in production today and what would require non-backward, or that would require backwards incompatible changes, for example. And so like when I think of core 2, I don't just think about functionality, but I think about how that functionality is expressed and how the upgrade and migration path would be for existing users, if that makes sense.
So this is a bit an implementation detail, but I think with Apollo, you guys got the link spec. This should be possible to say, okay, in Apollo, I mean, you're doing that at the moment, I think with provides, there's coming new, a different shape of provides. And then you have a new version that brings maybe a slightly different directive. Although I think most of the directives, like the directives that we have taken over from Apollo at the moment, 1-to-1, but let's see. But it's difficult to give you a correct answer now, where this spec is not implementable today.
Oh, sure, yeah, makes sense. Yeah, it's more of a general big picture question of like, you know, do we share a common kind of understanding of where that's headed? And yeah, that makes sense to me. Thanks, I really appreciate it.
Yeah. So at the moment, I think we have a rough common understanding, although there are details that are out of scope. There's also like there will be a lot of discussions on naming things, but I think that are all not blockers functionality wise. It's more like, does it fit into the spec text that we also have for the GraphQL core specification? And I mean, this is a spec text. This doesn't mean you have to name it like this in your product. Like you could still say this is, even if we say, okay, this is a source schema in the spec text, you could call that whatever, supergraph or whatever in your product.
That's true for names that we just like use in the spec, but for directives, for naming of directives, I think we do require compatibility. So
yes, and but as far as you know, you would also say this at the moment looks good. Directive wise, what we discussed, Martin, no?
Yeah, I mean, I think this makes a lot of sense. There's specific directives that we were having discussions about, like entity resolver, for instance.
Yeah.
But I think there's a broader issue here, but that's something that we'll have to sort of look at as things evolve. But there's a lot of existing usage out there, and like we have to weigh like making changes against the cost of migration. I think maybe the ECMAScript process is a good analogy here. Like looking at what's actually being used out there as input to the evolution process. I think that might be a good approach. We actually discussed also like looking at our respective schemas as a way of getting more information about usage of certain directives and how they are being used.
Yeah,
it's also good. It's also a good point in time to drop stuff which is there for legacy reasons, or is there with low usage, or is there because there was some other mistake done in design or whatever. Stuff that, I mean, it's a technology which did not exist, which does exist in a few years now. So usually you collect clutter. And when you look at certain definitions, there's also stuff in there where you're not sure why it's there, or it has very narrow application. And so for backwards compatibility, I guess it's also time to drop the stuff. So there should not be something in the spec which just is there because of
There's also what Benji rightly just posted is, like, if we decide on, okay, that was the design in Apollo Federation a few years ago for certain reasons, and we have a similar concept that is designed in a better way, it could also be that again we have a pre-processing step that that is able to translate that. But to make these decisions, let's see as we go along. Let's first try to get an optimal solution, and then look at concrete examples where I mean, you guys will come with maybe, okay, that will make it very, very difficult for us to migrate users over there. And then we can discuss that in on this particular issue, I would say. How we get it maybe refined that you can better migrate.
Maybe it's just my first impression, but that does seem a little backwards from what I would imagine like a specification process to be. Like the notion of coming up with what is optimal and then working backwards with bringing existing implementations into play feels exciting for sure. But I'm wondering whether the right mental model is to consider what users are using in production today as a basis, and to innovate on top of that once we have that crystallized in an initial draft, if that makes sense. Like the notion of capturing what is out there handling production workloads today, and then using this process through what we normally do in the GraphQL working group process too, of like then iterating from there toward an optimal solution, or whatever the current consensus is. Certainly up for discussion, but it's just and again, not completely attached to any one solution, but I'm curious what the group is, what the group's thoughts are on that.
Sure, but there are a couple of, like, I would say most of it is already in that way. The one change we did is that we don't have an underscore entities field, for instance, that is necessary. This is something that is very easy for a solution to integrate if they want to support that. But it's also, I think, in my opinion, one of the things that are not so nice with federation, as it removes type security at runtime, because like you have this any input, and also makes the subgraphs fundamentally vulnerable if exposed. Like, I mean, in your documentation, you always say don't expose them. But this is a thing that is fundamentally different with the spec we are writing at the moment and Apollo as a solution at the moment. All the other things, I think, are very much aligned. So we are basically going that way.
I agree. I think one other difference, but that sort of follows from getting rid of the underscore entities, is a different syntax for what we call requires. So it's require here. And we could go into more detail there, but it's basically we need a new way to sort of bring in those arbitrary well, like dynamic fields, and we can't just input them through root fields because those arguments are static. So we use variables for that, and require is a way of binding those variables. So that follows from getting rid of underscore entities. It might be a good design principle actually to sort of establish that that's as far as we want to take this. That sort of getting rid of underscore entities and replacing that with a notion of entity resolvers or finders is how we sort of see this specification evolving over what's being used right now. But if there is anything else, we would need additional discussion, I think. I think it's good to sort of stick to that core set of directives.
But that's also what we put in here, right, Martin? I mean, I discussed it with you.
Yeah, no, I agree. I just want to clarify for the rest of the group.
It's also about what's used in. I mean, looking at what's used in by customers in production is definitely the right starting point, because then you see what works and what doesn't. But from this on, it's also the time to to iterate on this, right? So it's looking what works in what's used in production, why is it used in production, and then specifying it in a way which is which this feature is used in or optimized for, and not have all the other things that are specified because of legacy reasons.
I can kind of see the point though, that spec first and then coming back around to feasibility afterwards seems like the right goal. Keeping it in mind while we go is helpful, but probably not the goal.
When we first set up the composite schemas working group, the aim was to capture the state of all the various different solutions and figure out what the commonality was that we could share. So I think this is definitely the right approach. But there's no reason, I think, that you can't attack it from both directions at the same time and sort of try and meet in the middle. It's always critical to keep in mind what is currently happening in production, though. We don't want to make it so no one can move to this.
Yeah, and also figure out what are the things that are not so nice in production. I mean, you can always learn from what is out there, right? I mean, that's also the same thing like we do with defer. It's a good example of how this changes over time.
Yeah, it's just important that you iterate, or that we iterate on what's being done now to make it better. Because if we just specify what's done now, then we just specify a solution, right?
Okay, so but like with the set, I mean, I put this set here in because it's not like we are talking about naming. We can talk about shape here, but like these were a bit the pre-discussions I had with Martin. What would be sensible to put in the spec scope, and that also is a bit what we are working on. This is at the moment the directive scope. Okay. Good. So as for the composition as lined out, and we are at the moment working on, we also have like a lot of text that I dumped at the moment. It's a bit from my text, a bit Martin's text. I'm sorting through them at the moment to get the best of both bits. And that's at the moment here in the temp document in this pull request. There's a bit of fundamental property text in there. And I'm at the moment also validation algorithms that we figured out, which align with the merge validation rules, also from Apollo, things like that. And at the moment, this is just a raw text dump. And I'm at the moment sifting through it to put it into the right pieces of here our composition of our composition chapter. And that is a bit the state of where we are. So composition is the main focus. I think that we will probably in the next 4 weeks have something here, but the satisfiability algorithm, I'm at the moment thinking through it, will take some time to get it right.
Yeah, to
Martin
make it
knows
understandable.
Yes.
Yeah. Yeah, and I think that's actually a good thing to keep in mind in general. Like it's not just about like being very precise in the specification, but it's also on like giving people a conceptual understanding of this whole federated architecture. For instance, really describing the reasoning behind some of the decisions we've made, like the design principles are a starting point there, but we also really want to describe the different composition stages, sort of describe what they are, why they're there, before going into detail on like the formal validation rules, for instance. So there's a lot of work to be done here, and some of it is really about understandability, I would say.
Yes, and like I encourage everyone to join in here. I know Azure guys are also now here, which is very good. If you have things that you think from. I mean, you also have a super graph solution, so please contribute ideas and issues to the spec repository, so we get everybody accounted for.
Yeah, I guess as soon as we go into, I know it will take some time until we're there, as you just said, Martin, but as soon as we go into these validation rules, which there will be many different rules, that's the perfect way to distribute work, because as soon as more people think into a problem, you have more brains on the topic. If you just read the specification, it's hard to spot problems. But as soon as you write an algorithm, everything explodes. So that's a really good point to get more people involved. So we have to take advantage of this point. That once we go into this validation step, that we try to involve more people which write validation rules to then find problems in the specification, because they have to think into the specification, not just read it.
Yeah, and that's why we initially also focused on a bit the design principles, so that this is clear to everyone. So this, again, I said that last time, but for the new ones here, just read through it. If you don't agree with something, open up an issue. Because that's as Martin said, we basically at the moment are specifying the idea, and then we can focus on the specific algorithms around these ideas. Any feedback? I'm not sure. Okay. Yeah, Jakob, just open a discussion. Yeah. Okay, that's a bit the status. If there is no more discussions, we can conclude.
Yeah, nothing for me.
Sounds good. Any action items that we noted here? I didn't pull any out specifically, but sounds like we're going to continue iterating, opening issues, discussions, things like that.
Yeah, so I think the main action item is to review that section 1. That's been mentioned a few times. So everyone should read that and make sure that they agree with it, because that very much is setting the scope of what it is that we're trying to achieve here. After that, I think, yeah, getting involved in all the existing stuff. Is that right, Michael?
Yes, that's right. Because like these are the design principles that we are calling out, and also the scope of the spec. Pretty much is making up the scene. And then directive-wise, you can also have a look over it. Is in source schemas, you have the directives. So the text, don't look at the text, but it's more like, okay, we agree we need something like an entity resolver, if we call it finder or whatever, that is at the moment an issue. But we also have like provides external, that are the core directives that we're gonna work on. As I said, shape and shape can change as we discuss in the weekly meetings. And if you immediately think, okay, I want to give feedback to the directives also, you can also just open an issue. Like for instance, we already have one issue on the entity resolver. Martin opened that up regarding should we name it finder or entity resolver. So as laid out, this is stage 0. It's so we discourage anyone from implementing this.
Do not do.
Yeah, do not do yet. Sounds good. Okay.
Yeah.
Awesome. Thanks, everyone. And thanks for your continued work on this in the secondary meetings as well. Sounds like we're making excellent progress. It's very exciting. I look forward to seeing you all next month and stay in touch.
Awesome.
All right. Enjoy the rest of your day.
See ya.
Bye.
Bye.
Thank you, everyone.
Bye bye.